Hey, it's Coach Latham, your math coach, and today we're going to talk about lines and curves of best fit and box and whisker plots. And as always, we're going to try and do it all in under 15 minutes. If we take a look at this picture right here, we see we've got some blue dots up at the top. They appear to be moving in a curved direction. We've got some red dots down here at the bottom, and they appear to be somewhat modeling a straight line. It's important that you can look at a set of data and kind of get a feel for whether it's modeling a straight line or a curve. Now we're going to give you directions for each question, which will tell you how to go about it, but I did want to show you an example and just point that out. We're going to concentrate on these red dots to start with, and we're going to see what we can do to find a line of best fit. In other words, what's the equation of a line that best approximates the relationship of these red dots? I'm looking at this right now, and it looks to me that we're going to have a slope of about 1 because it's going up about as much as it goes over. Looks like it's going to have a y-intercept in here somewhere around -1. Those are just ideas that I have going into the problem. But we're going to do the actual math. Over here I have collected all the coordinates of those points. Like this one right here is -5, -5. The next one is -4, -3, and you can see I have them all listed over here. So go ahead and get your graphing calculator out, and I'm going to show you how to load them into the stat function. Okay, I have my calculator out, and I've written down those coordinates that we had on the last page. The first thing I'm going to do is hit the stat button to get to the stat page. Now I've got 3 choices on the top: edit, calc, or test. Now we're only going to use edit and calc today. But we're going to start in the edit mode, and it's on number 1 down here, edit. So I'm going to go ahead and hit enter, and I get a bunch of tables that look like this: L1, L2, L3. And I'm going to put my x coordinates down L1, and I'm going to put my y coordinates down L2. You can see I've got a couple of numbers left in here from my last problem. So to get rid of those, I'm just going to hit the up arrow until L1 is highlighted. I hit clear. I hit the down button, and that clears the row out, or the column out, and I'm ready to go. My first coordinate was -5, -5. Well, it was -5 as the x coordinate, so I'm going to hit -5, enter. The x coordinate of the next one was -4. I'll hit -4, enter. And I'll go ahead and hit pause now while I put the rest of them in. You go ahead and put all the coordinates into your calculator. All right, I'm back. I've got all my numbers typed in. All the x coordinates are going down line 1 right here. All the y coordinates are going down line 2. You always want to double check yourself to make sure that you've put them in right. Bad data will get you a bad answer. Once you're sure that they're all in, we're going to hit the stat button again. This time we're going to hit the right arrow to highlight calculate at the top of the screen. So we're on the calculate screen. And then this is going to be a line of best fit. We said they look like a line, so we're going to go down and hit number 4 because that's linear regression. That means line of best fit. We hit enter. We get the calculation screen. Yes, we put the x's in line 1. We put the y's in line 2. So we're just going to scroll down and highlight calculate and hit enter. And then like magic, we're going to get the equation of this line. Now it's written in this way: y equals ax plus b. They tell us that the slope, or a, is 0.61 when you round to the nearest hundredth, and b, the y-intercept, is going to be -1.54 if we round that to the nearest hundred. So we quickly have the equation of the line for this. If we were going to write it out, and you'd want to look at the answers that you have available to see what kind of rounding you would need to do. But we would simply write this equation as something like this. Or, we could put a 4 there. You're going to take a look at your answers, and they're only going to have one that's going to match what you got on your calculator. So this is the equation of that line of best fit. So now we're going to turn our attention to these blue dots up here that we said kind of model a quadratic curve. The only thing that's going to change is what button we hit on the calculate screen. Putting these dots into the calculator is going to be the exact same process. I have the coordinates for all those dots written over here on the right. you may want to hit pause and jot them down, and then go ahead and type these into your calculators under line 1 and line 2. Okay, I'm back. We've got them typed in on the edit screen right here, so we're going to hit Stat again. We're going to go over to Calculate, and like I said, this one is a quadratic fit, so that's going to be number 5 this time. So we're going to go down to number 5, and we're going to hit Enter. Yep, I've got my X's in L1, my Y's in L2, so I'm going to scroll down to Calculate and hit Calculate and hit Enter. And here's my answer. So when I go to write this one out, since it's a quadratic equation, we've got an x squared term in it. But the equation is going to be y equals, and we'll round this to the nearest hundredth, so it's going to be 0.33x squared. This one is just a 0, so we don't even have to put a plus x in there. And this one is going to be 2.8, so we could say plus 2.8. And there's our curve of best fit for this one. Here's a problem that's very similar to some of the ones that have been on previous SOL tests. This time we're going to use the line of best fit for the data table below to predict the value of y when x is equal to 23. All right, so let's go ahead and get into this problem. Our first goal is going to be to type these numbers into our calculator. And when you type them into your edit screen, it's going to be just like this. I've got my x's down there, my y's down here. I'm going to hit Stat. I'm going to hit Calc, and it's a line of best fit, so I'm going to go down to number 4. I'm going to hit Enter. Then I'm going to scroll down to Calculate, and I'm going to get the equation of the line. And through the magic of the calculator, this is what I get. So it's going to be y is equal to, and it's going to be 1.8x minus 11.8. So that's what I get when I work it out. Now the question said, what is the value of y when x is 25? So what I'm going to do is say y is equal to 1.8, but instead of x, I'm going to replace that by 25 minus 11.8 to figure out what the value of y is going to be. I'll pick up my other calculator and do the calculation, and I get 33.2 for the final answer. 33.2 certainly seems reasonable to me. If you look back at the original problem, you see that the values of y are going up as x is getting bigger, and I think 33.2 looks pretty good. So that's really everything that you need to know about lines and curves of best fit to do well on the SOL. We're going to turn our attention now to box and whisker plots. And box and whisker plots are interesting things. First of all, these are the whiskers. Right here is one whisker, and over here is another whisker. And these whiskers represent 25% of the scores. 25% of the scores within any data set is on each whisker, and then you've got a box in the middle, and this part of the box up to this line right here represents another 25%, and then the other side of the box represents the final 25%. Of course, if you add 25% and 25% and 25%, you get 100% of the scores. So all the scores are represented by this box and two whiskers. Now the line that's in the middle of the box is the median of the data set. It's the number in the middle when they're arranged from the smallest to the biggest. This is the median right here. And so we have half the scores to the right of that, and we have half the scores to the left of that. Some questions that you could be asked about this box and whisker plot is, what is the median? Well, this line right here corresponds to a score of 60. So that means that on the test that these students took, that 60 is going to be the average or the median score. We could ask about the range. The range is going to be the difference between the highest score, looks like somebody got 100, and the lowest score, 20. So 100 minus 20 is going to give us 80 for an overall range. A new term that you might not have heard before is called the interquartile range. And what that means is the range of the box, the range of the interquartiles. So if we were going to look for the interquartile range, we would note that this box goes up to 70 and it goes as far down as 40. So the difference between 70 and 40 is going to be 70 minus 40. It's going to have an interquartile range of 30. And finally, we'll ask the question, what percent of the scores are below 40? So 40 is right here. So if we were looking for what percent of the scores were below 40, well, the only thing below 40 is this whisker. And this whisker represents 25% of the scores. If you had been asked what percent of the scores are above 40, then your answer would have been 75%, because here's 25%, here's 25%, and here's 25%. So just based on the 40 being at the bottom or the left side of the box, we know 25% of our scores are below that, and 75% of our scores are above that. And here's a typical type of question that you might see on your SOL test. We've got two sets of data here represented by box and whisker plots. We've got test A, which is up here on top. We've got test 1 and test 2. And we've got a box and whisker plot that represents both of them. If you're just taking a look at them individually, test 1 has a range from 20 up to 100. Test 2 has a range from 20 up to 90. Test 1 looks like the students did better on. The median score for test 1 is at 60, whereas the median score for test 2 is at 50. So let's go ahead and get into these questions here. We're going to call them all either true or false. Test number 1 had the higher median. Test number 1 had the higher median. Well, we said that the median on test 1 was 60 and the median on test 2 was 50, so that's going to be true. Test 1 does have the higher median. So let's move on to the next statement. The next statement says test number 2 has the larger range. All right, the range for test 2 goes from 90 to 20, so that's a range of 70. The range of test 1 goes from 120, so that's a range of 80. So test 2 actually has a smaller range, so this statement is going to be false, and we'll put an F there for that. The next statement says test number 2 had the larger interquartile range. Remember, the interquartile range is the distance from the right side to the left side of the box, or how wide is the box. The interquartile range for both of these goes from 7 to 40. They both have an interquartile range of 30, so this statement is going to be false. One's not bigger than the other. They're both the same. The next statement, 50% of the students scored below 70 on test 1. Scored below 70 on test 1. Well, right here I've got 70 marked on test 1. What percent scored below that? Well, we got 25% here, we got 25% here, and we got 25% here. This is going to be false because it should have said 75% of the people scored below 70 on test 1. And our last statement says that 75% of the students scored above 40 on test 2. Here's the 40 on test 2 right in here. 25%, 25%, 25%. Put them all together, that's 75%. And so that one would be true. And so this is everything that you need to know to do well on the SOL test on box and whisker plots and lines of best fit. I would strongly recommend that you get with your teacher to get some SOL practice problems and try it out. Every one you do, you'll get a little bit better at typing things into your calculator without mistakes and getting good answers. Now keep studying. You can pass this thing.